Hello everyone, in this video we're going to learn how to solve square root equations. Alright, first we're going to learn how to solve square root of A equals B. Note that square root of A is defined when A greater than or equal to 0. Step number 1, we're going to write the given equation in this form. Step number 2, state the domain restriction, which means A must be greater than or equal to 0. If B has variables, you need to let B greater than or equal to 0 and combine the domain restrictions. Step number 3, square both sides to get A equals B squared. Step number 4, solve the equation from step number 3 for ask. Step number 5, make conclusion and check for extraneous answers using the domain right here. Now, we will learn how to solve the square root equation square root of A equals square root of B. Step number 1, we need to rewrite the given equation in this form. Step number 2, state the domain restriction. We're going to let B greater than or equal to 0. Step number 3, square both sides, we get A equals B. Step number 4, solve the equation from step number 3 for ask. And step number 5, make conclusion and check for extraneous answers using the domain right here. Now, example number 1. Given LS equals 2 square root of 2s minus 3 minus 5. Find f of 4, which means we substitute 4 for s, right? So it's going to be 2 square root of 2 times 4 minus 3 minus 5, right? And it's going to be 2 square root of 2 times 4 equals 8. Minus 3 is going to be 5. Minus 5. This one is the final answer. Now question B. Find the zero of LS, which means you're going to solve the equation LS equals 0, right? So we have 2 square root of 2s minus 3 minus 5 equals 0, right? So we're going to use the first case, right? Square root of A equals B, right? So we're going to add 5 both sides. It's going to be 2 square root of 2s minus 3 equals 5. Divide both sides by 2. So it can be square root of 2s minus 3 equals 5 over 2, right? Now we need to have the domain. It's going to be 2s minus 3 greater than or equal to 0, right? And then s greater than or equal to 3 over 2. Alright, so we're going to square both sides. It turns out to be 2s minus 3 equals 25 over 4, right? And add 3 both sides, so it could be 2s equals 25 over 4 plus 3, which is 37 over 4, right? Now divide both sides by 2, so s equals 37 over 8, right? Now this number is greater than or equal to 3 over 2, right? So the solution should be s equals 37 over 8. Now question C. Solve LS equals 4. So we have 2 square root of 2s minus 3 minus 5 equals 4. Alright, again the domain is right here, right? So we're going to add 5 both sides. It's going to be 2 square root of 2s minus 3 equals 9, right? Then we divide both sides by 2. It will be square root of 2s minus 3 equals 9 over 2. And we square both sides, it could be 2s minus 3 equals 81 over 4, right? We are going to add 3 both sides. It could be 2s equals 81 over 4 add 3, right? And it's going to be 93 over 4, right? And divide both sides by 2, so s equals 93 over 8, which is greater than or equals 3.5, right? So this one is the solution. Now question D. Determine if LS and G of S equal S intersect. Alright, so in order for these two guys to intersect, we need to let ls equals g of s, right? So we have 2 square root of 2s minus 3 minus 5 equal s. We're going to solve for s, right? So we're going to add 5 both sides. It could be 2 square root of 2s minus 3 equals s plus 5. We need to find the domain, right? So domain is going to be s greater than or equal to 3 over 2 is the same thing as above, right? Now we're going to square both sides. This guy turns out to be 4 times 2s minus 3 equals s squared plus 10s plus 25, right? I just use the complete square formula. A plus b all together square is going to be a squared plus 2ab plus b squared, right? So I'm going to distribute this one, so it turns out to be 8s minus 12 equals s squared plus 10s plus 25. So it's going to be s squared. Subtract as both sides, it could be plus 2s, right? And add 12 both sides, it could be plus 37 equals 0, right? Now we're going to use the discriminant to solve this quadratic equation, right? So discriminant b squared minus 4ac is going to be 2 squared minus 4 times 1 times 37, right? Because a equals 1, b equals 2, and c equals 37, right? Now this guy actually less than 0, right? So the equation has no solution, right? Now if this guy has no solution, then ls and gls right here will not intersect, right? Now let's move on to example number 2. We're going to solve this equation, right? Now first we need to find the domain, right? So domain is going to be 2s plus 1 greater than equal to 0 and s greater than equal to 0, right? These two guys right here. Then it's going to be s greater than equal to negative 1/2, right? And s greater than equal to 0. We're going to combine these two guys, so s greater than equal to 0 is the final domain, right? So this guy turns out to be square root of 2s plus 1 equals square root of s plus 1, right? Now we're going to square both sides, right? So the left one is 2s plus 1. The right hand side we just use complete square formula, right? So square root of s squared is going to be s plus 2 square root of s plus 1, right? So I'm going to subtract s both sides and subtract 1 both sides. So 2s subtract s is going to be s, right? 1 subtract 1 is going to be 0. So it could be s equals 2 square root of s. Now I'm going to square both sides again. So it could be s squared equals 4s, right? Subtract 4s both sides. So it could be s squared minus 4s equals 0, right? Factor s out. So it could be s minus 4 equals 0. So this one is the 0 product. Each of this one must be equal to 0, right? So you will have s equals 0 or s minus 4 equals 0, right? So we're going to solve these two guys. So it could be s equals 0 and s equals 4. We're going to check with the domain right here, s greater than or equal to 0. So these two guys are solutions, right? Now, example number 3. We have two different ways to solve this problem. Alright, the first way, we just distribute this one using for the method, right? So square root of s times 5, it could be 5 square root of s. Square root of s times square root of s could be minus s, right? Negative 2 times 5 could be negative 10. Negative 2 times negative square root of s, it could be plus 2 square root of s equals 4 minus s, right? Now I'm going to combine like terms. This guy turns out to be 7 square root of s, right? Now this guy and this guy are the same, so it's going to be cancel out, right? Now subtract 4 both sides, it's going to be negative 14 equals 0, right? So I'm going to add 14 both sides. It could be 7 square root of s equals 14, right? So square root of s equals 14 divided by 7, it could be 2. Square both sides, it could be s equals 4, right? Now, don't forget to find the domain, right? The domain is going to be s greater than equal to 0, right? Now, we solve s equal 4, so this one is the solution because it's greater than equal to 0, right? Now, second method, I just keep the left hand side, right? The right hand side, I'm going to use difference of two squares. It could be a squared minus b squared equals a minus b times a plus b, right? Now, a in this direction is 2, and b in this direction is square root of s, right? So it could be 2 minus square root of s times 2 plus square root of s, right? So I'm going to subtract both sides by this guy. So it could be, observe that this guy opposite, right? So I need to make them the same. So I'm going to distribute negative 1 over here, right? So this guy turns out to be positive, right? It's going to be negative 2 plus square root of s, right? So it could be square root of s minus 2 times 2 plus square root of s. Note that you distribute negative 1 to the first factor only, right? You cannot do both, so keep that in mind. Equals 0. Alright, so look at this guy and this guy, they're both the same. I factor this guy out. So square root of s minus 2 times, the first one has 5 minus square root of s, right? The right side has plus 2 plus square root of s right here, right? Equals 0, right? So it could be square root of s minus 2. Now simplify this one, it could be 7, right? Equals 0. Because 7 is different from 0, so you only need square root of s minus 2 equals 0, right? Add 2 both sides, so it will be square root of s equals 2. Square both sides, so s equals 4. This one is the final answer. Example number 4. Now it's so complicated if you square both sides, right? So we just find the domain, right? So the domain of this one s minus 5 greater than equal to 0. Domain of this one is going to be 5 minus s greater than equal to 0, right? We solve this guy. So s greater than equal to 5, and this guy s less than equal to 5, right? Now, in order for the number to satisfy both inequalities right here, s must be equals 5 only. Now we substitute 5 for s over here. So we have the left hand side is square root of 5 minus 5, right? Plus square root of 5 minus 5 equals 1, right? This guy equals 0 plus 0 equals 1. So 0 equals 1, which is impossible, right? So the equation has no solution. Now example number 5. This one is the type square root of a equals square root of b. Now we square both sides, it's going to be 10 minus n equals n minus 4. Now we're going to subtract n both sides and subtract 10 both sides. It could be negative 2n equals negative 14, right? Divide both sides by negative 2, so n equals 7, right? Now we either find the domain or we substitute 7 back over here to check, right? So I prefer to find the domain, right? Domain should be 10 minus n greater than equal to 0. N minus 4 greater than equal to 0, right? We solve these two guys, so n less than equal to 10 for the first one, right? And n greater than equal to 4, right? So we combine these two guys, it's going to be n greater than equal to 4 less than equal to 10, right? Now we solve n equals 7, satisfy this domain, so this one is the solution, right? Now example number 6. We need to find the domain 2s minus 3 greater than equal to 0 and s minus 1 greater than 0 because it's on the denominator. So if this one equals 0, the whole thing is undefined, right? Now we're going to solve this one, s greater than equal to 3½ right? And s greater than or equal to 1. Combine these two guys, we have s greater than or equal to 3½ is the final domain, right? The equation right here becomes, we're going to square both sides, so we have 2s minus 3 over s minus 1 equals 4, right? Multiply both sides by s minus 1. So this guy turns out to be 2s minus 3 equals 4s minus 4, right? Now subtract 4s both sides, so it could be negative 2s, and add 3 both sides, it could be negative 1, right? Divide both sides by negative 2, so s equals 1/2, right? Now s equals 1/2 less than 3 over 2, right? So, no solution. Now, example number 7. We're going to find the domain, right? So, domain should be the one on the radical side greater than or equal to 0, right? So we have this guy, and this guy, right? Now, this guy in the denominator, this guy in the denominator. So, these two guys must be different from 0, right? So we have square root of s minus 5 not equal to 0. Square root of s minus 6 not equal to 0, right? So we solve this guy. We have s greater than or equal to 0. Now, add 5 both sides and square, it could be s not equal to 25, right? This guy, add 6 both sides and square, it could be s not equal to 36, right? So this one is the domain, right? We're gonna cross multiply, right? So it could be, now we just FOIL this one, so square root of s times this one, it could be s, right? Square root of s times negative 6, it could be negative 6 square root of s minus 2 square root of s plus 12, right? Equals s minus 5 square root of s minus 4 square root of s plus 20, right? Now we combine like terms, so it could be s, this guy turns out to be negative 8 square root of s plus 12, right? S, this guy turns out to be negative 9 square root of s plus 20, right? Now both sides have the same s, it could be 1, right? Now we're gonna add 9 square root of s both sides, right? So it could be square root of s left. Subtract 12 both sides, it could be 8, right? Square both sides, it could be s equals 64, right? Now we're gonna compare this one with the domain right here. So this one is the solution, right? The last example is really challenging. Alright, so we're gonna subtract this guy both sides, right? And then subtract this guy both sides. So this guy turns out to be difference of two square, a minus b times a plus b equals a square minus b square, right? This guy right here is called the conjugate of this one. This guy is called the conjugate of this guy, right? So I have a minus b, this guy is a, this guy is b, right? And it's a plus b, right? So I multiply the top bottom by a plus b, which is, the left hand side is 1 over s minus 1 square minus 1 over s square, right? The right hand side, we have a minus b times a plus b, it could be a square minus b square, right? So it could be this guy square, it turns out to be s plus 2. This guy square, it could be minus 3s plus 1. Don't forget the negative side right here, right? Over square root of s plus 2 plus square root of 3s plus 1, right? Now the left hand side right here, we need to cross multiply, right? So this guy turns out to be s square minus s minus 1 altogether square over this guy multiplied by this guy, right? The right hand side, we just distribute negative 1, right? So it could be s plus 2 minus 3s minus 1 over square root of s plus 2 plus square root of 3s plus 1, right? S square, distribute this one using the complete square formula. So it could be minus s square minus 2s plus 1, right? Over s square times s minus 1 all together square, right? Equals negative 2s plus 1 over square root of s plus 2 plus square root of 3s plus 1, right? Now I'm going to simplify the numerator right here. So distribute negative 1, it turns out to be negative s squared plus 2s minus 1, right? Now this guy cancel out, right? Now I'm going to subtract this guy both sides. So it's going to be, alright, now I'm going to distribute negative 1 over here, right? So does that mean I get 2s minus 1, right? Now I'm going to factor 2s minus 1 out. So I have, now this one is the zero product. Each of this one must be equal 0, right? But this guy right here always greater than 0, right? So you only need 2s minus 1 equals 0. That's it. So s equals 1 half, right? Now go back over here. We need to find the domain, right? S minus 1 not equal to 0. This guy not equal to 0, so s not equal to 0. This guy greater than equal to 0, so s plus 2 greater than equal to 0. And this guy greater than equal to 0, so 3s plus 1 greater than equal to 0, right? S not equal to 1, right? This guy s not equal to 0, right? This guy s greater than equal to negative 2, right? And this guy s greater than equal to negative 1 over 3, right? Now we have s equals 1 half. That satisfies all conditions right here, right? So this is the only solution to the equation right here, right? And it's good time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand